a special parachuting design from our fuselage. Okay, we do not use one parachute, but we use at least 3 parachutes together pop up. Okay, and we can control the parachute to have a better wind rejection, to have very safe altitude landing. So right now here in Taiwan, we have some experimental base in Hsinchu. We have indoor facilities, and also in other places we have outdoor facilities to have our experimental drone being tested. Okay. Here are some project experiences. So this is the high payload teaser drone. The teaser drone means that you have your drone power supply from the ground. Okay, you have one cable connected to your drone. Okay, this is the test flight situation, so you do not observe the teaser wire here. But in fact, this is especially for the purpose of the teaser mode. Okay, so we have a very heavy communication relay and also a very special surveillance camera here. We have the EOIR and also the laser rangefinder function, 3-in-1 camera module, and also the very special communication relay on the drone. So this is for a very special mission. So the diameter seems very large right now. Okay, but right now we have a more compact one to have with the same payload and with the shrinkage of the decrease of the diameter of the propeller center to 2.2 meter. In the past it is 4 meter center to center. Right now it's 2.2 meter. Okay, here is the test of the teaser drone. Okay. Doesn't work to So this is the first generation. We have only 6 propellers and only 30 kilogram payload at that moment. And then we have the 6 axis but 18 propeller. In the indoor test, and this is the outdoor test. The hand cannot throw the button, so this is the indoor test for the fuselage reliability and also some communication control system signal. And this is the outdoor test. And later we have the more reliable 3rd generation fuselage with 18 propeller with enhanced motor and its driver. because in the beginning we used the commercial available motor driver, and we burn out the driver. It's poor for temperature sustain capability. So because it's very important to have very severe duty. So this is a wind rejection test. This is about 5 to 6 beautiful grade speed, wind speed. Okay, this is the follow me mode of the drone. So you can have the drone launched from the truck, but it will follow the truck automatically. So this is another utility drone. As you can see that we carry a water tank, just like the chemical spray drone, but we use this water to have the ceramic insulator being cleaned. Okay, so the ceramic insulator we have here is this is an old one. This kind of insulator is used in the power grid. Okay, the Thai Power company in Taiwan, they need the insulator to have the safe electricity transmission from the power plant to the transformer station, right? Okay. So it is very important to keep the insulator very get rid of the dust, okay? Because too much dust or any contamination can cause some spark or arcing on the insulator, then you may damage the power grid. Okay. So some fire incident occurred for the Thai Power company each year. And this is a demo, a small drone. This is a small drone to demo the AI function integrated with this drone. We use the JSON Nano module to do the edge computing, to distinguish the watermelon on the grass environment. So you will have the green background and how to detect the object automatically, and you will align your drone according to the axis of the watermelon, and then you have your grabs. You have your grabs tool to hold the watermelon and take to somewhere else. This is an interesting project that conducted together with the National Yangmin Jiaoda. Okay. This is for delivery purpose, and this is for agricultural delivery to carry the mango in Pingdong. Okay. So in 2017, we use our drone to do the chemical spray in Shiding, Shiding, the tea garden. And at that moment we worked together with Professor Huang in Huafan to have better distance control for the drone in the tea garden. And later in Miaoli, Tongluo, for such kind of plan, Hangju, for this kind of drone plane, you will have very dense leaves, and you need stronger downward flushing wind to have the leaves just dense together with your chemical spray to have better pesticide effect. Okay. So here I would like to talk some focus of our technology development. One is the powertrain, another is the fuselage. Okay, so about 5 years ago, we chose the internal combustion engine together with the lithium battery and our motor to formulate our powertrain. So usually we call this is hybrid power, right? This is a hybrid power source, and this is the typical serial type hybrid power, because this is just a pure genset. This is a pure genset to provide electricity for the electric propulsion motor. Okay, so from the genset you have the electricity, and also sometimes if you suffer from the gust of wind, and you draw some electricity from the lithium battery. Okay, so this is the basic control and power topology. And also this kind of hybrid also adapted to this kind of light aviation, personal light aviation, and also for the drone, the military drone or cargo drone. So I think that for the mechanical department, that many students already got the experience of the finite element analysis. Okay, especially for the structure or for the fluid dynamics. So you can use the computer analysis engineering software like ANSYS or other software to enable your design process to quickly verify your design concept, like resonance, your vibration mode or something like that. Okay. So then you can accelerate your design process, and you will pass the vibration test, and also some other tests like usually you will have the IP standard to prevent to prove the waterproof and also the dust proof. So, and for the propeller unit, usually we can enhance our motor or driver efficiency or reliability. So you can have the 6-phase design rather than 3-phase design. So you can have more redundant power delivery choice, because sometimes you will suffer from the motor fail in the air. So in that situation, you can switch from the 6-phase output to the single 3-phase output, or you can have other redundant design, like we have the double redundant design for our autopilot. Okay, so it is very common for the traditional aviation plane that you can have a redundant power source, like a redundant engine or redundant ECU or redundant oil supply, something like that. So this is a hybrid power system for UAV that we have this small one from 3 kilowatt for the surveillance camera, for the surveillance the drone, and also the bigger one for delivery service. And this is the motor power fail-safe control study. This means that if you have your hexacopter, that is you have 6 rotors, if one rotor or 2 rotors fail, then how to switch your control algorithm from the original hexacopter to a quadcopter, or even the triangular propulsion configuration. So these are about the quick diagnosis of your motor fail signal, and you have to judge very quickly that if you suffer from the motor fail. And also you can embed some sensors for the in the driver, but you have to have some software algorithm in your control system to ensure that you can have the proper response to certain motor fail situation. Okay, this is the final topic about hybrid fixed wing eVTOL development. Okay, because in the past the eVTOL issue is for the military purpose, but we want to enable the eVTOL, that is electric vertical and takeoff landing, vertical takeoff and landing drone, especially suitable or tangible for utility application. Okay, so and also we want to use these kind of eVTOLs for high payload application to achieve long endurance and a flexible deployment. With respect to multi-rotor drone, it will have a higher cruise speed, okay, and a more efficient propulsion efficiency, right? Because they have the fixed wing, and also they have the multi-rotor can have vertical takeoff landing. So especially for Taiwan, this kind of area, we do not have so many taxi the taxi place. So the drone airport is not everywhere. So the eVTOL right now becomes more and more important, especially for some rescue or delivery application. Okay, so like Amazon or DHL or many other delivery service companies, they are trying to verify is it the best solution for their longer range, like 15-kilometer delivery service application. So for such kind of eVTOL, there are some unmet needs like the aerodynamic efficiency and flight control capability. As I mentioned, that they have some weak points at the transition stage. Okay, so this is the typical battery-powered UAV. As I said, this is the 4+1 design. Okay, the 4+1 configuration. So you have the quadcopter and the one propulsion propeller. And some people in other countries, they also call the multi-rotor drone as the eVTOL, because they can also achieve the vertical takeoff landing. But usually we we mentioned such kind of hybrid fuselage, you have the fixed wing and the multi-rotor as the eVTOLs. Okay. So this is the desired range and the desired payload. But right now, currently, we just achieve such kind of payload or range. Okay, like 15 kilometer for utility drone. Okay, 15 kilometer or 40 or 60 kilometer for the utility purpose. So the most critical design issue is the propulsion approach and also the flight control agility. This is for this figure, it introduced the basic concept of the thrust density, okay, and the thrust efficiency, okay. This is about the thrust efficiency, the propulsion efficiency or thrust efficiency. This is about the thrust density. With the best thrust density, you can have your eVTOL as the Harrier, right? The Harrier fighter just take off from the ship, the battleship. Take off from the battleship that you can carry more than 8 tons or 10 tons. Okay, that is because you use the vector thrust from the turbojet, right? From the turbofan or from the turbojet. So you have very high thrust density, okay? But you have very low propulsion efficiency. So you cost a lot of fuel to have your vertical takeoff and landing. So for the very famous fighter F-35, right? For F-35, the B version, F-35B, so you sacrifice a lot of payload for the vertical takeoff and the landing version, the 35B version. Okay? So this is about the takeoff weight, the maximum takeoff weight, and but you have very poor fuel efficiency. But for the helicopter, they have lower cruise speed, but they have the best hovering efficiency. Okay, that is because you have the best propeller size. The bigger propeller size, you can have the better hovering efficiency. Okay, so for multi-rotor, you have a little bit poor hovering efficiency, but you get the redundant advantage. Okay, redundant advantage with respect to the helicopter, with respect to single rotor. So this is how and why the multi-rotor can survive for many utility applications. Okay? So the single rotor helicopter is very efficient and has very good flight control paths, but they are not so reliable in some certain situations with respect to the multi-rotor. Okay? So the compound or the compromised design, we said the tier rotor or the tiered wing design is that you have your fixed wing together with the tier rotor or tier wing. Then you will sacrifice some cruise mode efficiency. But you will have the vertical and takeoff landing with efficient fuel efficiency. Okay. So right now we have another choice for the personnel carriage application, like the hover bike. Usually for hover bike, for one person, you can have this kind of propulsion unit we call electric ducted fan. Electric ducted fan consumes the electricity from the battery, but they have also moderate or better thrust density with respect to the open propeller. For the traditional open propeller, you have the best thrust efficiency, or called thrust ratio. But if you have higher speed for the electric ducted fan, usually you need 10,000 at least, or 20,000, or even 50,000 RPM for electric ducted fan, because you have smaller size, you have smaller diameter of the fan. So you need higher speed, higher rotational speed. Usually at least 10,000, 16,000, like for the 500-meter diameter. Okay. So you will have a better thrust density, so you can shrink the diameter of the propeller for the propulsion unit, so you can embed this kind of EDF inside your hover bike. Okay. So this is also lighter. For if you want to achieve the same thrust like 50 kilogram, then you can have lighter weight, okay, and also smaller size. But this is not so efficient as the open propeller. Usually you only have 2 gram thrust per watt. Okay. For open thrust, at the same propulsion level, you usually have at least 4.5 or even 8 to 10 gram per watt for larger size. Okay. Okay, this is some preliminary test to install this kind of electric ducted fan together with the fixed wing 2 years ago. And this is the integration with the fuel cell in the main cabin to power the cruise mode propulsion propeller. Okay, this is a 1.1 kilowatt propeller, and for these 6 EDF, they consume at least 15 kilowatt. Okay, but this is for cruise mode, so they have the fixed wing to provide the basic buoyant force to sustain the attitude. And also the flight control algorithm is very important for such kind of eVTOL, because you will have very breakthrough design, innovative design, so you have to verify if it is stable in the air for longitudinal or lateral control. The stability, you can use the simulation software to quickly verify your concept, and then you can have more thorough study using the